Okay, so first up, we're going to cut our carbon fiber tube. So depending on which kit you got, some of you will have different lengths of carbon fiber. Some will have 4 pieces and some will have 2. You should have enough carbon fiber to make all of your arms and also all of your legs. Really, while in the magazine we published certain specifications for the arms and for the legs, it really doesn't matter as long as they're even. So, based on what we've provided in the kit, you should be able to get a 4 legs and 4 arms, and probably a little bit left over just from our tolerance and things like that. So first things first, we want to mark our carbon fiber to get it ready for cutting. And because making sure these pieces are even is more important, you may like to cut it in half before you get going, or just be very careful with your measurements, because making sure they're even is more critically important than making sure that they equal exactly 234 millimeters like we say in the magazine. If they're say 230, 240, as long as they're even, you're not going to have any problems. But if you are a bit longer, you may run into some problems with the silicon wire or something like that, but fairly easily overcome. So with the carbon fiber, because it's black and it's very glossy on the surface, it's sort of hard to make any markings. One way that we suggest is using some brown masking tape, and grab your trusty tape measure. And so we're going to go around about 234 millimeters. So as long as we can find that spot there, then bring your pieces of carbon fiber together, get a little piece of masking tape, place it in the middle there somewhere, and then you can make a nice precise measurement at 234 millimeters and carry on the process. So make sure that you've got your pieces marked accurately, and always cut very carefully. With carbon fiber, you do want to try and avoid getting any pieces in your skin or clothing. So wearing overalls and coveralls, you can buy a plastic disposable like a mesh overall from places like Bunnings for about $5, used for painting and asbestos removal and things like that. They're not a bad way to go as well. It's a little bit like working with fiberglass. The fine particles will get in your skin and just really irritate you for quite some time. And if you are cutting a bit of a dust mask or something like that, it's not a bad idea either. Just for got to be careful of our health and safety. All right, so once you've got these marked out and you know that everything's accurate, you can go ahead and cut. I'm not going to show you cutting them here, but you can use just about anything to cut. A hacksaw, a drop saw, anything like that. If you are using a saw of any kind that has like a drop saw, any sort of power tool, try and get a vacuum to suck up any of the carbon fiber dust as it comes, because you really don't want that getting in your machinery. It can damage the motor bushings and things in your drop saws as well. So once you've got your markings, then you can go and cut. And I won't show you the cutting here because it's pretty noisy and not much to see. But once you've done all that, then you basically get your 4 arms and your 4 legs all in one. And as I said, making sure that they're critically the same length, within about 1 millimeter or 2, is a good thing to do. And here we've got them quite accurate. And anything outside of that is going to cause you flight problems, and just place a little bit of extra strain on the motors. Hawk will actually compensate for any imbalance, but you'll reduce the flight performance, and everything will just have to work that little bit harder to run properly. Okay, so now that we've got our 4 arms and our 4 legs, it's not a bad idea to check fit the motor mounts. These are 3D printed parts and things can happen. So it's not a bad idea to just, before we get out the Araldite, just insert the arms and insert the legs, and do this for each of the ones that you're going to produce, and we can make sure that everything's okay. Once the araldite comes out, everything gets infinitely more messy. And now there isn't a stop to stop the leg going too far, so you just want to insert the arm and then the leg. So put in the arm all the way, and then the leg. It's not a bad idea to line them all up as well, just to make sure that everything looks even and balanced the way we expect. After all, anything that's out at this point is far more easily corrected than once you start aral-diting things in. So we can put them all right. As you can see on this top one, everything looks pretty good. And as you can see on this front one, everything is pretty even as well. So we're in a pretty good spot to start aral-diting in our arms and our legs. This process does need to be done first, and it takes a little while to dry as well. So it's you know, it's not a bad way to approach things and do it first. Okay, so in your pack, you would have got some araldite. The araldite may be a little bit different to this one, but it all works the same. It's basically fast and exceptionally strong bonding epoxy, and so this stuff is really not something you want to get anywhere that you don't want permanently stuck. But yeah, we'll use this and we'll assemble our motor mounts. So you would have received some araldite in your kit, and if you've bought your own, doesn't really matter what sort of araldite you use or what sort of epoxy. It's just got to provide a really strong bond. And epoxy adhesive will just be a little bit stronger than super glue, which can be a little bit brittle, but super glue can help put things back together sometimes as well. So the best way to mix this epoxy, it's a two-part, so it does nothing while it's separated, or at least very little. So we need to mix it, and usually the best way to mix it is just on a piece of cardboard. Sometimes it will bleed through paper, so anything you don't want stuck down, it's a really good idea to make sure that it's definitely nice and thick, so that it's not going to stick and bleed through and permanently affix some paper to your bench. So you just have to take off the caps. Sometimes you'll have to cut it, and usually comes off pretty easily. And we'll just squeeze out a good portion here, about the size of a 50-cent piece, and just watch that it doesn't come back on itself. I like to use just a paddle pop stick, mix up this epoxy, and you'll see it instantly starts to change state. It goes from like a bit of a runny honey into something a little bit more sticky and viscous. Give it a good little mix. We don't need a huge amount, you don't want to overdo it, but we do want a good amount of epoxy on here. So first things first, we take our arm and we basically give it a good coating on all sides, and be fairly liberal. You want a bit extra on all the sides, and then we just stick it in here. Make sure it's nice and firm and fully seated in. You might want to give it a wiggle on all the axes. Make sure it's fully seated, and you can clean up any excess and just run your paddle pop stick around there. Make sure it's fully seated. Once it's bonded, it is really hard to move. Then second step, this is on our first leg, and just seat it nicely in there. We do want a bit of bleed through here because we want it to be nice and strong. Okay, so we place this one to dry. Make sure everything's in there nice and firm, and it will sit there. And then we repeat the process. Make sure you take the leg out when you insert the arm, because it will drop down and take up the space that the that the arm is meant to occupy. Just make sure we clean it up. Really, the cleanup's just for aesthetics. It doesn't matter too much, so don't worry too much about it. But we do want it to be nice and solid. Now you do want to work pretty fast. This usually has about a 5-minute hold or a 10-minute hold. So you don't want to muck around forever. And don't overthink it too much. It does dry clear, so it doesn't matter too much for the aesthetics overall of the hawk. Also making sure that things are still looking about what you expect and fairly even. Just all these cross checks along the way just help us get a consistent result. Sit on all the sides. Take out the leg. Push it all in and give it a wiggle. You'll find by the third or fourth you've got a bit of an action down as well. Push everything in nice and firm. Lucky last. Now we could have gone with screws instead of araldite for these mounts, but it's just more screws, more rattles. If you find you've got extra pedal pop sticks, you can just use one of those for cleanup too. Makes things a little bit easier. We could have gone nuts and bolts, but the araldite was determined to be better. Less nuts and bolts is a good thing. Helps keep down the weight a little bit. It also just less things to go wrong and less parts. So it also makes the process fairly straightforward to replace. A bit of cleanup. It does start to get messy at times, but just don't worry too much. Wipe the excess off. I said it doesn't really matter too much how neat the job is. Dries clear and looks pretty good anyway. There we go, there's all 4. So we want these to cure sort of overnight before we do too much more with them. And we want to make sure that these bonds are really solid before we go too much further. So we're going to let these sit overnight and then we'll come back and we'll do some more. Okay, we've come back the next day and our legs and arms are nice and strong. You can see that the araldite's gone nice and clear. You can still see where it's overflowed a little bit, but it doesn't really matter. Everything's quite strong and tough and shouldn't provide too much problem for anyone. So what we're going to do now is we're going to mark out the hole spacing for the legs, for the arms to go into the main chassis. Now it's important to note in the instructions in the magazine, we actually do this in reverse process. We put the arms into the chassis first and then we attach the legs. It doesn't really matter which order you do this in. It's really just a personal preference and however you'd like to tackle it. So really up to you. As long as these 2 steps happen, everything's going to go together fine. So what we're going to do is take a little bit of tape, get our masking tape, and we're just going to label each one of these basically as a 1, 2, 3, 4, so that we know which one is which. The hole spacing in the chassis shouldn't really be any different based on which size it is, but it just helps make sure that everything goes together smoothly. So what we're basically doing is providing a writable surface, because we can't really write on the carbon fibre. And then we're just going to locate each arm to a respective position. Again, it doesn't really matter which position it is, but it will just help keep things in order. The spacing here on the motor mount does equal pretty closely to what's on the chassis. So if you keep it inverted the way we have it, then you will see everything pretty clearly. It'll also be nice and level, so you don't have to accommodate for any angular adjustments or anything like that. They really just make everything pretty straightforward. Most of this process is fairly self-explanatory, but we're detailing it anyway as part of this full build video. Ordinarily we like to use gaffer tape or something like that too, but it's a little bit thick to use here. The carbon fiber rods are pretty snug into into the chassis, so anything like cloth tape will actually provide a little bit too much resistance, and you might find yourself with some problems. Now, what you'll notice here is we've got a locator, which is for the button assembly. This is a hole up this end, and here on the back is the 4 mounting holes for the GPS mast. And so you just want to pay attention and make sure that we get the numbering the right way around. If you have a look in the guide on, this is issue 10, page 81, there's a numbering sequence just here for 1, 2, 3, and 4. Now, we don't actually have to follow that in order to locate what we're doing here. This is purely just for our own purposes, for our own drill template. So what we can do is place our chassis on top, make sure everything's nice and firmly in place. And if you can't get your pen through, you may find that a screwdriver or a scribe or something like that is a better way to go, or take the filament out of the inside of a pen, and then you can get it down inside the prints. Try and get a good location mark on here. And of course, before we've done this, we've just pushed everything in nice and tight, just to make sure it's at the edges of where we want it. And so we're going to cheat a little bit here. And just say 1. Now this is face up for me, might be face up for face down for you. But we're just going in a clockwise rotation. And then carefully pull that chassis off there and make sure that we match. So we go 1, 2, 3, 4. As you can see, we've got pretty good dot marks here. So it's pretty easy to find our drill points. Put a larger circle there, just so if you do get a bit of pen on there, then you're pretty sure what one is your intended mark and what's not. You can see that it's still pushed into the center there pretty well. So we're going to go ahead and drill these out. You want to make sure that you use a drill bit that's suitable for the M3 screws that we're putting through. So you should be able to match up a drill bit. We don't want too much extra room in here, because even though the compression will hold everything in place, you really want to make sure that we're not taking away any material that's unnecessary. It just helps keep everything rigid. It's good practice to just use the smallest drill bit you can while still getting the screws through neatly. And those are the M3 screws that are included. And we'll go ahead and drill these now. All right, so we've got our drill press set up here with a 3mm drill bit. You might find that a 2.5 is enough. If you've got imperial drill bits, you just have to find one that matches. But a 3mm looks pretty good for us, and we'll make sure that we can get the screw head through. without creating too much of a hole. So we're going to fire this up and off we go. And that's it. The excess carbon that comes up here, it's usually left on the top. We really want to try and shake that away and keep that away from anything electrical. It does tend to get a little bit nasty, and it's pure carbon, so it does conduct electricity. All right, so now we're going to put our arms into our chassis, and move these things out of the way a little bit. So remember, we've really only located 1, 2, 3, 4, just so we know what we've drilled and what we've marked. And so we can put our arms in appropriately the right position. Then we can get to work. So what we can do at this point is take off the tape. Really don't need that anymore. If there's any little burrs or anything on your drill holes, just give those a clean up. It'll just help everything mate just that little bit better. If you like, you can pre-run one of the bolts through it just to make sure that everything goes through okay. And these holes look pretty good. All right. Now the chassis with the top, with the arms for the FPV mount, this is the top. It doesn't really matter, but that's the way we've designed it, and that's the way it's balanced as well. All right, so now that we've got our everything drilled, we're going to start assembling our frame. Now, it's important to note that this is upside down at the moment in this configuration. We actually want our legs to come down this way, so we're actually going to assemble everything in reverse. So the easiest way is to take our top mount, which has to go onto our top chassis, and then run your screws through the body. Now, depending on your print, these are 3D printed, so you may have to either give them a bit of a ream or just grab your screwdriver and screw them through. It's not a bad way to do things because it does actually help hold things in place and stop them falling out anyway. You shouldn't need to drill it out. The 3D printed holes are pretty good, but if they look like they need a bit of love, then you've already got your 3mm drill bit there. You can just ream them out a little bit. Again, we don't want to do it unless it's absolutely necessary because we want everything to be as tight as possible. So we can just start getting things located here. Now make sure you're using your 32mm screws. They are, there's 4 of them included, and these are the ones that do encapsulate the board mounting plate, the 3D printed board mounting plate into the top of the chassis. They have a little bit of extra length just to make sure we can get them on. Unfortunately, there's about 7mm difference between 32mm and the 25mm screws. Some extra 32s or maybe sort of 28s would have been nice, but the 25mm screws do just fit. You just got to put a little bit of effort into it to get everything to bolt up nicely. So you notice that we've sort of located everything around here, and so this is so we can start transferring all of our arms, and once these go in, should just punch in like that, and then you can screw them up the rest of the way. Now you can see that this is starting to take shape, which is always very exciting. It is possible to, if you would like, to use araldite on the main chassis and the arms as well. It's really not required because we've got 8 bolts. We've got 2 bolts on each arm that are holding things in. And so if anything does break down the line, the araldite can be a bit of a pain to remove. It really serves its purpose well on these arms and legs, but for the main chassis, we just really don't need it. There's enough, especially with the size of the plate, there's a good 1.5 inches of track there. So we really just don't need to overdo it. So once your arms are sort of loosely in play, we can start to screw them in a little bit further. They're a very fine threaded bolt, so it does sort of feel like it's taking forever. Give it a little bit of love to get through the carbon fibre on the other side. This is one time where using a 3mm drill bit does really help, because it means you've got a little bit of play. You don't really have to thread the bolt through there, and you're not going to have a tough time getting everything located where you want it to go. If you've got an electric screwdriver, it's probably not a bad idea either. Now, if you didn't have a drill press, you may find that your holes haven't aligned properly, and you'll just have to try and massage those into play. A drill press really does make this much simpler than using a hand drill. Just the accuracy of the drill press. So even if you have a friend that has a drill press and you need to go over there and do it, it's probably going to save you a little bit of hassle trying to get these all on. Just take note too that the mounting plate here, it sets the flight controller forward of everything else. Sets the flight controller back, because this is the back. And so it should just fit just in line with this loop, which is what we're using to feed our strap through. I'm going to get these screws pretty much all the way in. It's not a whole lot to go on now, so it's don't do them up too tight. There's not a whole lot of thread that they're going to nip onto. You just want them firm so that you can get everything else mounted. Lucky last, at least for these 4. Now if you find that it doesn't quite come up, just make sure you have everything aligned. I want to just give it a little bit of a massage. And by massage we mean brute force. There we go. You will get a little bit of carbon out of these at this stage as well, at least most likely. So just be conscious of that and just keep it clean. There we go. So we can take our base plate, making sure that you're aligning the hole to the hole, or the triangle to the triangle. It really just helps you ensure that everything's pretty kosher. And with a bit of luck and a bit of force, you'll get that on pretty nicely. We'll see that nut's just popped out there. It's okay, we just nip him up. And push it all the way through. So you notice that it's starting to take shape. Okay, so now we're just going to put the nuts and washers on the bolts that we've just put through. You want to use a bit of Loctite here. We did include Loctite in your kits. For this one, we may disassemble this, so we're not going to use any Loctite right now. But we'll show you the same. So with the thread locker, just put a little bit on the thread, not too much. It gets pretty messy pretty fast, but then everything just goes together as per normal. So a little bit of thread lock, place a washer on the base and a nut, and just get it started. These nuts are usually pretty good and don't cross thread too easily, but just take care. The bolt itself will usually hold tight enough through the body that you can get the nut started as well. Just helps you nip everything up just that little bit faster. So once you've got those started, we won't do them up too tight right now. Yes, we will. Now these ones have a really small spanner. If you don't have a small spanner, you can just use a pair of pliers. And we don't want to over tighten things, but we want to make sure it's nice and firm. Should see it start to grab and get a little bit tight. All right, so this is a good time to just check that everything's sitting pretty well firm and as you expect. So pop hawk up just like you'd expect and just check that everything's okay. And if everything looks okay, then we can put in our other nuts and bolts. And again, these should pop through just with a little encouragement. May find that you need to they just need to find those holes. Shouldn't be too much trouble. If you do have trouble finding the holes for the second set of nuts, second set of bolts, then you can just easily disassemble. Might just be a case of turning it while giving it a bit of a wiggle, like it was in that case. Again, this is where the drill press really made light work of things, because if we were using a hand drill, then we've had a little bit more trouble. Things just don't quite line up the same way. Even then, this one's giving us a little bit of drama, but a little bit of force will just help it find its hole, and then it'll start screwing in. Now we're going in. Sometimes just changing a screw helps as well. Swap it out and the other one fits better for whatever reason. Just starting to pop through now.
Now these screws are only just long enough to get a washer and a nut on there, and so you'll need to do them up fairly tight just to get them to show proud as much as you can. Then you should be able to get a nut and a washer on there. Electric screwdriver, good investment. Now you may find that once you start to do these up, that your hawk's not precisely square. It's not going to make too much difference. In this case, if we put a ruler on it, it'd be barely 1 millimeter. So don't worry too much about it. Comes down to the smallest of a fraction of a degree, and really not too much. Got a bit of excess 3D printer gunk. We can just trim that off here. Now, one little tip, if you find that you can't quite get the washer on here, you may want to just put a nut on the end and let that grab and bind through. It'll start to pull everything through nice and tight, and then start to bed the screw head into the top. It means that you can then loosen it back off. And with a bit of luck, you should be able to get the washer on there the second time around. The washer's not even actually that important. We haven't seen Hawk actually do too much damage to the chassis even without a washer, but it's good protection anyway. If you still find that you're struggling, maybe if your 3D print is a little bit thicker, and you can simply push it through, and you can even start to countersink the heads if you like, and you really only need a fraction of a millimeter and about a half a turn on the nut to get it started, and then everything will start to pull pretty tight for you. They sometimes get lost in here too. There's always a couple of bolts that end up on the bottom of the garage floor when you work on the car. again, just grab your pliers. Careful not to put too much stress on the Hawk chassis while you do this. You see we get a few turns in there, it's plenty. Quite get that on. Sometimes it just needs a little extra persistence. Now, if you would feel more comfortable having longer screws here, you can replace these with 32mm screws to get a little bit of extra length. Sometimes it will depend on the thickness of your prints and a lot of other factors as well. You may also want to just back some of these off a little bit while you get them all to bite, because it will start to tension on the opposite side and try and split that gap on you. If you still can't get it to bite, just grab a little G-clamp. Now we want to compress nice and close so that we're not flexing it out. If it still doesn't get you anything, back the screw out. If you don't have a countersink, you can use just a large Phillips head screwdriver, and you'll start to see you get a little bit more buried in there. So you're going to have plenty of plastic to retain this screw, as long as you don't take out too much. I only need a mil or so.
then we've just bitten up there. Go around to make sure they're all fairly tight. Again, we're only using plastic and little tiny M3 screws. You don't need loads of torque, but here we go. Perfect hawk frame. All right, now we're going to do a few exciting bits, and we're going to mount the motors, and then we'll work our way back to the ESC and the parts in the middle. So you'll notice that these motors come in a little pack, and they come with the brushless motor itself, the prop mount, and some screws. So this is something that we have to mount on ourselves. And we're not actually using the star mount, but we are using the prop mount itself. So just take off the nut and the washer. Now these are like a Phillips 0, something quite small, so you will need a fine screwdriver to do these. You just simply position overhead and drop them in. Right, we'll just grab a small screwdriver. So this is like a super precision screwdriver. I think it's, I don't know what size it is, but it's maybe a 00 Phillips or something like that, but it's a pretty small screwdriver. Now these don't have to be done ultra tight, just tight enough. So then till we're ready to put our props on, we may as well keep this all safe. And we can move on. Now this base and the extra screws you don't need. We've actually provided replacement screws which are a little bit longer to make it through the mounts. So now we just have to repeat the process for all four motors. Doesn't matter which one's which at this stage. Because it just becomes, the rotation is done with the wiring. So all the brushless motors are actually the same. It does help if your screwdriver has a magnetic end, which a lot of these little ones do. It just means that the screws, being so tiny, you can't really grab them with your fingers, so it just helps you get the job done fairly easily. If you really wanted to, you could put a little bit of Loctite on these, but I don't suggest that it's actually required. Just make sure they're nice and firm. All right, we've got our 4 motors. It's not a bad idea to keep these extra screws just in case they come in handy at some point. I'm sure a lot of us like to keep these things in our toolbox. You never know when you'll need really, really tiny screws. All the extra rubbish you can just throw out. Now at this stage it doesn't matter which motor is which. They've all got to go on, and as we were saying yesterday, just need to match them up so that your leads are going approximately the right way. Really just want to make sure they're not pointing back out the wrong way. You'll run out of wire if you're using the supplied silicone wire, and really just want to keep things as neat as possible. So really that's the only consideration. So you may have got hex screws, or you may have got you may have got hex screws or Phillips head screws. Either really works the same. And usually we'll just get these started. Flip your hawk over, you can see what you're doing a little bit more. And just getting the screws started make your life a little bit more easy. Now the fixings that we're using here may be marginally different from what you got in your kit. The reason being we actually sold all our kits, even our demonstration kit, which we didn't anticipate. So we had to rebuild kits rebuild this particular hawk with additional hardware. So once they're started, you want to get them going just till it starts to protrude through the base. Just so you can start to locate things. Once you've got your first one nipped in there, everything will become just that little bit easier. Just take care not to cross thread. If you've got them into the base firmly, then it shouldn't happen, but like all these screws, just like a bigger screwdriver, it's quite easy to do. Not exactly high tensile screws, they're just enough for what we're doing. And now your 15mm screws will be just long enough. We really don't want them too long. Now once you've got 2 screws pretty much in, before you've really bolted them up tight, try and get your others in as well. You can also see through the bottom of the mount, there is actually, you can see the spindle, which you may be able to see there. You can see the spindle for the motor, and that helps you know that you're on track as well. So you can use that to aid with your location. Once you've got 2 screws in, the other 2 should go in pretty well, but make sure they're all started before you start to bolt them up tight. And once you're pretty well tight, then you can firm them all up. Don't want to over tighten things. We're still using plastic brackets, and the extra torque is just going to place more stress on your mount. So you want it firm, but you don't want to overdo things. That's it. Now we've got our first bracket. And as you see, these brushless motors spin from the top and the whole outer body moves. And we're pretty much good to keep going. If you like, you can start all of your screws on the base. It's really a bit like putting on shoes and socks. You can put on the socks first and then the shoes, or one sock and one shoe. It's really up to you and what you prefer. Really all gets done anyway, so it doesn't matter too much. Okay, now we've got all our screws started. We can just work through. Take care that you don't pinch the leads as you do this. Now, if you protrude the screws about 1 millimeter above the base, then they will actually sit into the thread for the motor without biting. Sort of gives you a way to home it, so it's nice and secure without having to
screw too much in. And we might do it on all 4, and then we'll bite the rest up because we can flip it over. You'll notice that once you've located one motor, they all sort of sit about the same as well, so it will help you locate things a little bit more quickly. Like anything, the more times you do it, the easier it becomes. Also, just watch that your motors are sitting flush when you start to screw them up as well. It's because the holes in the mounts are only so big, the screws will actually create a thread through there as you go, and it makes it a little bit tough to pull the motors down. And so you may find that making sure they're flush at first, it means you can retain the thread through the 3D print, which further helps secure everything. We find that with appropriately sized holes in 3D prints, you almost have like a thread lock effect on the screws themselves, just from having so much tight thread, because there's no leeway in there because the screw actually created the thread itself. Okay, we've got our 4 motors. I'll just nip up the rest of the bolts. Remember to get all 4 started before you tighten them up to full tension. Electric screwdriver would be really handy about now. Lucky last. Obviously I'm right-handed, so this makes it a little bit easier with the right hand. Just one of those human things. There we go. Now we've got our 4 motors assembled. And we're ready to keep going. Okay, so at this point you should have all 4 arms and legs mounted. Your power distribution base, which is the special 3D printed base, and the main chassis mounted, as well as your 4 motors. And just double check that all your motors, the leads are pointing in the same direction. Not totally important, but it just helps you get a consistent weight balance and a consistent aesthetic for your drone. So what we're going to do now is we're going to start soldering up some bullets, which go connect the ESCs, which are the control modules for the brushless motors, to each of our motors. So this process is a little bit tedious, but we'll show you how to do, how best to tackle it. If you're familiar with soldering, then this won't be a problem for you at all. But we'll show you how to get it done anyway as part of the build video, and then we can wire up our ESCs and start getting everything together.